All right, so for this next one, it says this graph represents cosine of 4x. And then it says, what is the period of this function? Well, since we have the graph, the period just means one cycle. So from here to here is one full cycle. In other words, we're starting at a peak, we're going down to the valley and coming back up to the peak. So one full cycle is what we call the period. And so what we're looking at is how long from here to here does it take? So the period then is equal to, what is that, pi over 2? And that's it. Now normally, and I'd have to go back. Let me move this over. Normally, let's go back. We talked about this on one of the example problems. I think it was this one. The period is 2 pi divided by b when you have this function here. So let me copy that real quick, and we'll bring that into the slide, and we'll talk about that. So graphically, we're able to just look and see when the pattern repeats itself. But we could also do it algebraically. So according to this, y is equal to, this is the standard form of a transformation of a quadratic, or not quadratic, a trigonometric function, where if we have b times the quantity x minus c plus d, these are all the things we could do. Well, our function, and this is the same for cosine. So I could, because they're cofunctions of each other, once just shifted over a little bit. If I were to say cosine here, it's the same thing, because it is. So if I have f of x equals cosine of just 4x, if I distribute this through the parentheses, I would get 4x. But here's the thing. A equals 1. B equals 4. C equals 0. And D equals 0. But this little formula right here, 2 pi over b is the period. So the period, you could do this without graphing it if you had to. I would say 2 over pi, and then b is 4. So if I plug in 4, why is it 4? Because c equals 0, and if you distribute that through, you end up with 4x. So then 2 over 4 reduces down to 1 over 2, or so this would be like 1 over 2, or pi over 2. Okay?